Solving rational equations. Now we'll take a look at solving rational equations. The difference between equations and expressions, we have an equal sign. And so that means we're looking for the numeric value that makes these equations true. So we're looking for the answer to x. We do have to check our answer in these versus like a linear equation, because now whenever there's variables down in the denominator, that means that there's a possibility of your answer, you could end up getting, like, say, x equals 2 for this problem, and it's not going to work. It's going to make that term undefined, and so you'd have to throw that solution away. So you do have to check your denominators to make sure that it does not make any of the denominators go to 0 after if you've done your math correctly. Other than that, it will work. So we've learned quick ways to solve. These are like a proportion. When you have one fraction equals one fraction, you can set your cross products equal to each other. So we have 4x equals 5x minus 10, the distributive property. We multiply those two together. Now it's a nice linear equation. I'm going to get my x's together. Should have negative 1x equals negative 10. You don't have to write the 1 if you don't want to, but my goal is to solve for x. So I'm going to divide by negative 1 to both sides, and I end up getting x equals 10. Before I circle it, I make sure it doesn't make the denominator go 0, and I can check it overall. I plug a 10 in here and here. I'll get 10 over 8 reduced down as 5/4. It is the correct answer. And so that's an example of a fraction equals a fraction. The other type that I have on the board, this is a pretty difficult problem right here. It has a lot going on with it. But we can make them so they're not so bad. The deal is, in something like this, I see it's a rational equation. So I'm thinking, okay, I need to find the LCD of the whole fraction in itself, and that's what we've done, like with other fraction problems before. You find the LCD of everything and then multiply by that LCD to both sides. That guarantees you have no denominators left or no fractions left. And so that's what we'll do, is identify that LCD. So in order to identify the LCD, you need to factor all of your denominators. I'm just going to do this one right directly under it. These are already factored. This is x and x, and it's going to end up being plus 2 minus 1, which is actually these two factors. So the cool thing is the LCD then is actually just going to be x plus 2 times x minus 1. And so what I'm going to do then is multiply both sides by the LCD. What I do to one side, I do the exact same thing to the other side. Say x plus 2 times x minus 1, and now use your distributive property and multiply that through to each of the terms. So in this case, my x plus 2's are going to cancel. You could do side notes to show that, but if I think of these canceling, I'm just left with this times the top. X minus 1 times 1 is just x minus 1. The denominator is gone. Minus, watch for that minus sign now, because I have more than one term. I have a 3 there already. My x minus 1's cancel. So I'm left with having to multiply it by an x plus 2. So that negative is going to go along with that 3 and change both of those signs. Be really careful on that. Easy to make that mistake. Is going to equal my x plus 2, x minus 1 is going to wipe out completely in that one. So I'm just left with the numerator in this case. Now I'm down to, it looks like a quadratic to solve. So let's get this all combined. And I'm going to end up with x minus 1 minus 3x minus 6. I distributed my negative 3 to both. I have negative 2x minus 7 is going to equal my x squared minus 2x minus 11. So I have everything simplified on both sides of my equal sign. Now I need to get everything on one side, since it's quadratic, get one side set equals 0, and solve. So I'm going to have to add 2x and add 7 to each side. And when I do that, I'm kind of running out of space here, so I'll put it over here. And when I do that, I'll end up getting 0 is equal to x squared minus 4, because the negative 2x and 2x wiped out. This is great because it's a difference two squares. I know I can solve this by factoring. front term what's being squared in the front goes in the front, what's being squared in the back goes in the back, and it's plus minus. They end up being the binomial conjugates. Equals 0, we use the zero factor property whenever we see something like that, because now I can go, cool, I can factor this. The only way this is equal to 0 is if this factor is equal to 0 or this factor is equal to 0, and that's your only possible solution. It's called the zero factor property. So now I take each factor and set it equal to 0 individually and solve for my variable. And I should get x equals -2 and x equals 2. Now I have to really watch for, hey, do any of these actually have to be thrown away? I mean, do any of them make any of the denominators 0? Not the negative, or not the 2, because if I plug in 2, I'm okay. That'll end up being 4 in the bottom, that'll end up being 3 in the bottom. This factored out, if I plug in a 2, I get 4 times 1 will be a 4 in the bottom. But if I plug -2 in, I have an issue here and here. It makes the bottom 0, so I actually have to throw this solution away. Can't be a -2, so 2 is my only answer. And that was a pretty tricky one, but that's as tricky as they can get. They can get even a little bit worse sometimes, and there's also some where we can have like just equations where they're just all variables, and we have to try and solve for a specific variable. So I thought I would show you one quick one like that, because that'll kind of summarize all of the equations all in one video here. So the next type you might see is, if I had something like this, and I asked you to solve for y, and I gave you something like 1 over x equals 1 over y minus 1 over z. Here's a quick example of something like that where it's like, wait a minute, it's all variables, it's a formula. You might see something like this in electrical engineering, resistance formulas, stuff like that. How do I solve for a variable is down in the denominator? It's a rational equation. Well, if I want to solve for that in terms of the formula, I basically will find same rules, find the LCD, which is x, y, z in this case, because they're all factored and they're all relatively prime to each other. So multiply x, y, z to both sides. Distribute. Oh, I'm sorry, wrote that wrong. That's supposed to go like this. Here's my equal sign. So x, y, z to both sides. So I'm going to distribute on this one. So the equal sign is right here. So distribute this one through to both. Multiply this one to this one. So the x's just cancel here, and I'm left with yz times 1. Equals, on this one, if I multiply, my y's cancel, and I'm just left with the next z, and then minus, my z's cancel, and I'm left with just the next y. All right, so the fractions are gone. Whenever you identify the LCD and you multiply by the LCD, fractions are gone. Now the deal is, I need to solve for the variable they asked me to, y. There's 2 terms with y in it, so get those all on one side. I'm going to add xy to both sides then. Get my y's all together on one side. So now I have yz plus xy equals xz. Now what we do for something tricky, this is kind of tricky, what we do is I notice, hey, I have a y in each term, I can use factoring again to help me out. I'm going to factor out a y, and I'm left with a z plus x. Take the GCF of the y out is equal to xz. Now you actually have it. You just pulled out a y. You're left with a term like this, z plus x. We can write it as x plus z if you want to write it in alphabetic order. Doesn't matter. Divide by z plus x to both sides. And your final answer would be y equals xz. The book will usually write them in alphabetic order, so they'll say x plus z versus z plus x, but it does not matter which way you write it. I cannot cancel here because there's a separation of a plus. It's not a product, or this is not a factor. X is not a factor, neither is z down here, so I couldn't cancel the z's, and that's as far as you could go. Pretty tricky problem. We actually use this quite a bit in like a pre-calc class, or even in like in a trigonometry class where you'll use factoring to help you solve in that fashion.